Hello and welcome. In this video, we want to give you a short introduction of how you can make use of Matlab and Simulink software together with TwinCAD 3 to integrate your Matlab functions and Simulink models directly into our TwinCAD 3 real-time environment, and how you can then use those Matlab functions and Simulink models in standard industrial-proven real-time control systems. In doing so, I would like to introduce to you Matthias and Brecht from company Vintecc. They are customers from Backoff, and they will do the major part and introduce how they use Backoff components in their projects.
Hello.
Thanks. Hello.
So, thank you for being here and share with us your success story and how you use PC-based control and model-based design. Matthias, can you please introduce Vintecc for us?
Thanks, Fabian. My name is Matthias de Rizze from Vintecc, and I'm very proud to give you some insights on Vintecc. Creating smarter machines is our baseline, and that is exactly what we are standing for. We started in 2015 and grew out of 2 founders to a team of 23 experts in software design. Our focus is mainly on machines, or the machine environment, and we are specialized in some key areas of Industry 4.0. Our headquarters are based in Roeselare, Belgium. We have also an extra office in Leuven, and on short term we plan to expand to the Netherlands. We have 3 major business units. We have Vintecc Projects, where we focus on the custom development of machine software via model-based software development. And with Dual, we created an easy digital twin simulation platform. And thirdly, we developed also in-house Capture, a flexible and customizable data framework. Dual and Capture are standalone products which we offer to the market, and at this moment we are searching for partners worldwide. In our machine software projects, we often use Backoff technology, typically for standalone machines that need sensor processing and drive actuation. We are strong believers of virtual commissioning. We test the software against a digital twin before going to the real application. We have applications in logistics where we develop both HEV control software as the fleet management software, but also applications in weaving industry as well as in the food processing industry.
Okay, thank you very much, Matthias, for this very nice introduction of company Vintecc. Brecht, maybe we switch to you now, and can you give us an introduction of how you realize projects using Backoff technology?
Okay, so very often we work like this. We basically develop a simulation model of the machine, possibly even before it even exists, and we start to develop the control software in Simulink using simulation. When the actual hardware is available, the Backoff hardware is available, we generate code out of the Simulink model and deploy it onto the target directly. Most of the bugs should already be gone, or most of the control logic should already be developed even before the actual hardware is available. So that's how we accelerate the development.
Well, that's very interesting. So can you give us a little bit more in-depth into this Simulink software? So what role really plays Simulink software in the realization process, especially in this use case that you develop together with IRO?
Okay, so IRO is a machine builder which builds feeders for inserting yarn into weaving machines. They wanted to develop a machine to insert flat tapes without any twists into textile. This machine there was a control software developed for this machine using Simulink and simulation. So on the left you can see the Simulink model and the simulation model. You can see that we can follow the states in the control software whilst simulating the behavior of the machine. On the right, you can see the actual setup where we deployed the Simulink model onto the Backoff target and control the actual motors.
Okay, thank you very much for this introduction of the use case that you developed together with IRO. And can you now give us a a better understanding of how the target for Simulink from Backoff accelerated your engineering process, and what benefits do you see in the usage of the target for Simulink that we develop and offer to our customers?
Okay, so like I said, you can directly generate code which can be deployed on the Backoff target from Simulink models. There are several advantages. One of them is, of course, the speed of working. The second one is you can see a representation of the Simulink model straight into TwinCut, so you can follow all the signals in real time. A third advantage is that you can also connect the TwinCut system with external mode to the Simulink model, so you can follow the execution of the Simulink model in Simulink whilst being connected to the target. And the last example is for me that the target for Simulink well integrates with Simulink, so you can find all the code generation options straight in the Simulink settings.
Well, that's very nice to hear that you so intensively also use our target for Simulink and find so many good use cases for it. Let's switch a little bit to a similar topic. So what I know from the past is that you very intensively use Simulink together with control logics. Is Simulink, to your opinion, the future PLC programming language?
Yes, for me, Simulink is a very nice way of programming because it's very graphical. So basically the code you have in Simulink is, for me, some kind of documentation already. You can also use this visual representation of the code to explain it to profiles which are more mechanical, for example, or which are not involved with programming the control software.
Well, that's a very nice understanding of your use case of Simulink together with PLCs and with controls or machine controls. Maybe now switch to the Backoff system in total. So can you give us a small introduction of how the Backoff system in general, so all of our components, help you in realizing your projects?
Yes. So for this project, we used a lot of standard components of Backoff I/O, and next to that, we used the AX8000 drives to achieve a very high-performance control system. In combination with the ethercut communication between the I/Os, the controller, and the drives, this resulted in very high performance, which we needed because we wanted to control the tension during the very fast infeeds of the weaving machine.
Well, that sounds fantastic that you also have very good experience with the Backoff system in total. So let us focus a little bit more on the aspect of the IRO use case with this feeder machine. So can you point specific aspects of the Backoff system that exactly made the difference for this kind of project?
Yes, for this project, the drives were very important. So we wanted to achieve very high performance on the control loops. So the Backoff drives nicely integrate with TwinCut, and you can add them in the drive manager, where you can see a visual representation of the control loops inside the drive, so torque control, velocity control, and position control. And you can tune the control loops whilst running. So that helped us accelerate developing the system and achieving the right performance.
Well, that's also very nice to hear that also in this use case with your feeding machine for weaver industry, you have very good experience with all components from the Backoff system. Thank you very much for these insights. Matthias, can you give us a short introduction of your future plan from a technological side and maybe also from a economical side?
Yes, of course. Well, at Vintecc, we believe the future of machines is smart, virtual, and artificial. That's why we invest in creating the right tools, also to make sure no software development or software project is too complex for us. We already experience more and more requests for artificial intelligence techniques. That's why we also invest a lot of efforts to build this expertise in that domain. The combination of digital twin, data intelligence, and model-based design makes us the ideal software partner for a lot of companies. For the economic future, we want to set up more and more partnerships worldwide to use our in-house development tools to help us or to help to create smarter machines worldwide.
Well, thank you very much for doing this video with us. It has been a lot of fun to see how you use Simulink, how you use the target for Simulink from Backoff, and also the Backoff system in total. And also, thank you very much for sharing this information about your project that you did together with IRO. So, thank you very much for watching this video. If you want to know more, just visit us on www.backoff.com.